I promised you code, and here it is. In this episode, we're going to write the movement code in the object-oriented programming language C# in Visual Studio and bring it to life in Unity. If you don't know what I'm talking about, I recommend you watch episodes 1 and 2 first. They explain step by step what software you'll need. Let's not waste time and get right into it together. Hi, I'm a part-time indie developer and illustrator. I've gained my knowledge through thousands of online tutorials, and now I want to give something back and share these skills with you. If you like these videos, subscribe to the channel to not miss new videos coming up, and if you want to support me, check out my website that contains my published games and a detailed dev blog and much more, or hit me up on Twitter. So we have a player on our floor, and now we want this player to be movable. So we want to move it up, down, left and right. Before we do this, I will add to the player certain components that make us able to do this. And there are, I'd say, a million ways to achieve player movement, but we're gonna do it this way. We're gonna add a component to our player. So select the player and in the inspector go down to add component and search for rigid body 2D. There are two rigid body components. Don't pick the one without 2D, pick the one with 2D. We're making a 2D game. How did I find it? Again, I click add component and here is a search bar on the top. Of course, I can also go here and try to find it, but if you know how the component is called, it's easier to find it up here. So I type in RIG and I find rigid body 2D. So if I press play, which I can do up here, something will happen. The player will fall down to eternity. So if I zoom out, you can see the player is falling down because we just added physics to our game. So this is now behaving like a falling body. And of course, everything falls downwards. So we have a mass that the player has of value 1, and to prevent the player from falling down, we can just go and set the gravity scale to 0, so it has no gravity now. So let's see if this worked. Yep, the player is not falling down. If I set this to something very low, like 0.5, it will just fall slower, but it will fall and of course accelerate. So, and if I pump this up very high, it might just disappear within a second. We can look here how fast it will fall. Woof, and there it is. It's gone. So, we set this to 0. Something that can happen is that you now start to change certain things. For example, the gravity. Yeah, of course, now it worked. And you think, oh yeah, 45 is a good gravity. And now you leave the play mode, you will see it snaps back to 0. All the changes you do them while not playing the game. So if I have it in 0 and I think, I'll change it while playing because I think 0.1 is a better gravity, just copy it by Command C or Control C'ing it, or you can also go to rigid body on the top and hit copy component, then leave the play mode, and you can assign it now by just going in here and pasting the value you wanted, or by paste component values. Okay, and this is our starting point where we start to code. So I'm going to the assets folder, and I'm just like before with the graphics folder, right clicking, create folder, and I'm gonna name this scripts. And inside the scripts or folder, I'm going to right click again, create, but this time it's not gonna be a folder, it's gonna be a C#. This is C, this C hashtag is pronounced C# script. And when it's created, it automatically gives us the option to rename this script, and we will call it player. And now look how I type the name. I don't make spaces. I just capitalize the first character of the new word, like player movement. And this is a very common way of naming. This player movement script is now created. And the first thing that we're gonna do is we're gonna go to our player. There are now several options how you can add a script to a game object. You can just take it and drag it onto the game object. Or you can, I'll remove this here shortly, go on the script and remove this component. You can do the same thing we just did by going to add component and search for your new created script. Here we have it, player movement. Or I'm gonna go on the player, drag my mouse cursor into the scene view field and press F on my keyboard to focus on the player. I think it's also possible to just drag it like this onto the player. Yes, it is. So I've dragged it onto the player by dragging it in here on the object. Now it doesn't do, of course, anything. We need to put some logic into this script. So I double click it, and for me it opens Visual Studio for Mac. You can of course use other scripting software, but I highly recommend this one. Okay, now inside of this script that is called player movement and is part of mono behavior, and let me explain this mono behavior shortly to you. Mono behavior means, I know this might not be 100% right what I'm explaining, but mono behavior means that you can take such a script and drag it onto an object that is holding and also executing this script. If you have a script that is a mono behavior, and for example it sits on the player, and the player it is not activated. I'm back in the Unity editor, selected the player, and I unchecked this checkbox here, then the mono behavior script will also not be executed. So keep this in mind. We don't need these two functions at the moment, so we're gonna delete them. And this will show you one thing that is already important. After I've done something in the script, at least in Visual Studio, you'll see that the cross up here became a circle, which means I need to save the script, which I do by Command S, the shortcut Control or Command S, and now it's saved. So if you program something and it doesn't execute in the editor and it doesn't throw any errors in the console, it's often because you simply didn't save the script. Now you see it starts with curly and ends with curly brackets. These are, I think, on my MacBook, they are when I hold down the Option key plus 8 or 9, it makes these curly brackets. And they always go around pieces of code that needs to be executed. For example, this whole class, this whole script, everything that is happening between these two brackets. For example, we have a method that is called void walk. Then I close them with these normal brackets and complete this with the curly ones. So now I've created a method that stands for walking, and in here I can make a code that makes the player walk, for example. So, and it would throw an error, for example, if I delete. Okay, I'm just gonna save this and show you that nothing happens because everything is set up right. And Unity always needs a short time to compile all the scripts that is indicated by this loading circle down here. So be patient if Unity takes a while to compile everything. But if I, for example, now delete this bracket here and save it, Unity will be most likely throwing an error pretty quickly. Yes, and if you go now in here, click on this error, on this alert message, it says that something is not right in the assets folder. That's right. On the in the folder scripts. Okay. And here on the player movement, say CS means C# script. okay, something is in here that is not doing well, and it has an error code, and it says curly brackets expected. And the cool thing now, if this doesn't work in all cases, but in this one it does, if I go over here, I already know where the error is, and double click it, it will automatically jump into my script and tell me where the error is. And this is also indicated by this red wavy line here. So it already told me that it's expecting a curly bracket. So I'm gonna give this script one more curly bracket and save it and check again. Yeah, everything seems to be fine except this warning. There are inconsistent line endings. Yeah, this is dependent on your system. If you're running on a Mac or on a Windows, this might look a little different. For now, just clear it. Okay, but we don't need this method at all. For the moment, we're gonna start different. So keep in mind, you have these curly brackets that you're gonna need very often. So check how you're gonna type them on your individual keyboard. First of all, to make our character move, we want to access the rigid body component that we've put on him or her. So we have this rigid body component and we want to access it through script. Therefore, we're gonna use public, and now we type rigid body 2D, and you see Visual Studio already suggests me what I can put in here. So I'm gonna select rigid body 2D, and I give this variable a name, just rigid body 2D, but with a small r. So this here in blue is the variable type of rigid body 2D, and this here is the name. We're gonna access later on this type by using the name. And maybe you've seen it already in the editor. If I just save this, remember to save. If we now switch back to Unity, we see that our player movement script that is sitting on the player got an empty slot that is called rigid body 2D, and you see it has capitalized the R and it has made a space between the 2D. And the cool thing now, because I made it public, I can now simply take this rigid body 2D component and drag it into this slot. Bam! And now it's already connected. The player movement script rigid body 2D component is connected to the rigid body component of this player. Easy. There are other ways to do it. For example, if I make simply a rigid body 2D component, and I'll name it private rigid body 2D. Why private? Because it's exactly the same as if I would make, instead of public, the private keyword first, but you can also just leave it. If I save this now, you will see there won't be another slot popping up. I can, for example, at the start method, you remember this one was already present in the script because this is executed at the very beginning of the, when you press play, actually before the first frame. Then I can access this differently by, for example, saying that this variable equals get component of type rigid body 2D, and this would work as well. But then it would need the start method to then connect this variable name. We've connected the rigid body component of the player with the script, and if we want the player to move, we need movement speed. So I'm gonna make another public, but this time it's gonna be a public float movement speed, and I'm gonna give it already a default value of 5F. Something that I forget to mention is that you end all your lines by a semicolon. I use on my keyboard Shift and the comma to make this symbol. Maybe it's different on yours. I'm using a German keyboard here. Furthermore, you've seen I've just made a comment into my code. If I do the exact same thing, let me just copy, paste it here, and do the same thing without these two slashes at the beginning, you see that some stuff is underlined in red. I'm gonna save this now, go back, and I see that here is an error popping up, and I can't even start the game. It says all the compiler error needs to be fixed before you can enter play mode. Yeah, nothing happens. This is because comments for your code, for example, you say, okay, I need this variable for blah blah. All this stuff can be done right after you put two slashes in front of it. So this is basic commenting code. Gonna delete this stuff and go back here. So you don't need this. This is just for you, that you know what I'm talking about, and to help you make this character. So public float. What is a float? A float is a decimal number. You can't see it right here. I can also write 5.0 f. Floats, I'm gonna do the same thing here. Floats are decimal numbers, for example 0.1 or 23.7 and so on. Next variable we're gonna need, before I continue, let's just save it and look what Unity does. I think it will get rid of this error. Yes, it will. And now we see we have a movement speed variable that we can adjust in here right in the Unity editor. And we can write 34.3 and it works. We can also go over the variable name, click it and drag it around. So you can, this is indicated by these two arrows on my mouse cursor, and you see I can also manipulate the value right here. But we're gonna go back to 5 and leave it there. But I don't want very high numbers here to appear, so therefore I'm gonna do something. I go down and I use these brackets here that I made with my keyboard is Option plus 5 and 6. I use the range attribute and I'll set a minimum of 1 and a maximum of 10 in here. And I'm gonna save it, so you see it's inside these brackets, and then range. This is the minimum and the maximum. I now have a slider that I can move between the minimum of 1 and the maximum of 10. And I can adjust it now much more easily and still do my typing in this field here. And the best thing, I can't go over 10 and of course lower than 1. Next important thing, I'm gonna need a vector 2 called movement direction. What we're doing right here is we're declaring variables. The movement direction is a vector 2 variable. This is a vector. So we have 4 directions at the moment, like up, down, left, right. And this is the Y and the Z, X direction, X direction. Positive, so let's say this is +1. We have 0 for Y and X, and we have -1 for the X axis, and +1 for Y and -1 for Y. And we see we have kind of the similar setup. We have up and down, left and right, but we don't go into the Z direction at the moment because we're making a 2D game. That means if we want to move the player up, we want to move it on the Y direction. If we want to move it down, the same but negative. The same goes with left and right, negative X direction and positive X direction. So this is our player window. We have the player right here, and if we move left, we do basically this. We go negative on the X direction, and when we move up, we go positive in the y direction. Alright, this is why we're using a vector 2. Now, what we're gonna do, we're gonna make our first function and actually let our player walk. Okay, we start by typing in void and write update. This is an already predefined method by Unity or by C#, because if I hit now only one bracket, it will already fill it up for me. The games are shown in the or rendered in the same way like movies are. So each frame you'll see an image, and that will change depending on the player's input for the next frame. And usually people talk about 60 FPS, which means 60 frames per second, which means 60 times the image of the game will be drawn within a second. And update executes each frame, which means if our game runs at 60 FPS, our update function will execute 60 times. Alright, and if it drops, for example, to 12, our update function will also only execute 12 times. And start, we had the void start. This executes before the first frame and never again. If you need to set up certain, when we for example did get component, we do this before the game starts, actually before the first frame. So why do we need update? We want to see if the player does any input to the computer, and therefore we will say movement direction dot x equals input dot get axis raw. This needs to be typed correctly, horizontal. If you make a mistake here, it won't work. So be sure to write horizontal correctly. Let's look at it. What did we just do? We said we have this x direction. So the movement of x is dependent on the input horizontal. So if you have a keyboard, you might have these arrows somewhere that point in several different directions. And these are set up to be the horizontal movement, left and right, or your A and your D key on your keyboard. Those are bound to the word horizontal that we're using here. So we're getting the raw axis, which means if we're pressing left, we will immediately get -1 on the x-axis. If we press right, we will immediately get +1 on the x-axis. If we don't press anything, x will be null. Not null, but 0, sorry, 0. And we can do the exact same thing for y. We replace the x through y, and we don't write horizontal, we write vertical. We save it and shortly go into Unity and start it, and we don't see any errors popping up. Let's just rename this vertical to vertical low, and you'll see as soon as it has compiled, we're getting an error that says input axis vertical low is not set up. So this is an important thing to keep in mind. The typo does matter here, so vertical is correct. Now, to make our character actually movable, this is already detecting our input. We'll make another update function, but this time it's gonna be a fixed update. And it's also auto-completing because this is a predefined Unity method. But what we're gonna do now is we're gonna take our rigid body component up here, rigid body 2D, dot move position, and this will take a few parameters. First of all, we will our start position, rigid body 2D dot position. This is our current position of the player in the world. And we will add now our movement direction that is defined by our input. So we take the current location and add our movement direction by times movement speed times time dot delta time. What this does, it will smooth out the our movement a little bit. So we're gonna save this, go into Unity, and now if you have the player selected and you did drag the rigid body component into your rigid body 2D slot and you did define a movement speed that is greater than 0, that's also the reason I set the minimum here at 1, and you press start, you should actually be able to move your player up and down, and also diagonally by just holding some of the keys. Perfect, that's nice. And if you play the game, you will actually see that the transform component is changing. So again, I start the game, and if I move up, you can see that the Y values are changing. Only Z stays at -1, what we have predefined. And this is what this move position does. Perfect. Now we have a moving player. If you should ever get lost again, you can reset this component, but keep in mind that Z should stay at -1. Phew, that's it. Good job, your player can now move, and as briefly mentioned in the clip, the whole thing usually works also if you connect a gamepad controller. Sometimes you just have to restart Unity to have it recognized as an input device by your computer. The next episode is all about collisions, thanks to which we can build and design our level and trigger events and touching certain areas in the game world. I'm looking forward for it, and if you have questions, as always, write them in the comments or connect with me. See you in the next episode.